All right, so in the first video, we took a maximization problem that we have here. And again, we're only considering maximization problems where all the variables are non-negative. We are not restricting the variables to being integral or whole numbers. That's a separate problem that we'll talk about later. And the numbers on the right-hand side of these other constraints are all positive numbers. And generally speaking, the numbers in here are going to be positive too. Because in a general sense, the typical problem is to create two products, X and Y. How many units of each product, X and Y, do I need to make to maximize a profit based on some numbers of available resources, where those different, in this case, three different resources are needed to construct those types of products. So this first inequality is just saying each unit of X requires a single unit of resource 1. Each unit of Y requires 2 units of resource 1. So once I decide on what X and Y are, I will know the total amount of resource 1 units that I've needed to use. But whatever that number is, it has to stay lower than 150 because that's all I have. All right, so what we did in the first video was convert this problem to a new and equivalent problem by adding 3 slack variables. And all this does is it changes these 3 equations in our constraints to equalities. And what's going to happen is once we find our decision for X and Y, we're going to know values of S1, S2, and S3, and those values are going to tell us how many units of each of the 3 resources that we started with we actually still have left over. So it's helping us keep track of what resources we have left over. And then in the second video, we showed how to convert this problem into what's called a simplex tableau by just keeping track of the numbers in the equations. So the yellow part in the middle and the green numbers on the right, those are just reflecting those 3 equations from our constraints. The labels on top are just the labels of our variables. The labels on the left are telling us the variables that are non-zero for this decision. And this initial decision was X and Y are both 0. So therefore, S1, 2, and 3 are starting as the total number of resources because we haven't used any yet. Because we haven't made any products yet, our profit is 0, which is in the lower right corner. So we want to try to find a new decision, which is going to give us some profit and will still be feasible. So how we're going to do that is through what's called pivoting the tableau in a certain specific way, which is called the simplex algorithm. So the simplex algorithm, in this step, all we're going to do is decide on how we're going to choose the way we're going to manipulate these equations to get a new decision. All right, and then in later videos, we'll actually show what you actually have to do to make those calculations in Excel. So at this point, this applies to any simplex tableau that you have. If you have a simplex tableau, it could be the 3rd or 4th step of a problem, it could be the 10th step of a problem, it could be the 1st step of a problem. Once you have a simplex tableau that's set up correctly, this algorithm tells you whether or not you need to do another step. If it tells you you don't need to do another step, that means you're done and you've found the optimal decision. If it tells you you do need to do another step, then you do that new step. So the simplex algorithm is simple. It says, look at the numbers in the last row here in peach. The numbers below are variable labels. This is our objective, kind of displaying how our objective function is being calculated. And look for negative numbers. So if I have a negative numbers, I do, that means we don't have an optimal solution. So we want to actually do something. So we want to choose a column to pivot, and we want to choose a row from our, in this case, 3 variables on the left to pivot as well. So we need to choose a pivot column and a pivot row, because what we're going to do is we're going to choose either x or y to be non-zero in the next decision. But then in order to do that, we have to choose one of the variables s1, 2, or 3 to be 0. So we have to change two variables. We have to swap out either x or y with s1, 2, or 3. Now, looking at the tableau, you can actually see kind of what's happening here. The variables on the left correspond to the variable columns which have a 1 and all zeros. So those columns are called pivoted. They're already in pivot form, so those columns correspond to the variables on the left. So S1, 2, and 3 have that form. But X and Y don't, so we want to swap one of these out with one of these. So we have to do two things. We want to get a new solution, a new decision, which is going to give us a bigger value in this lower right-hand corner, a more optimal profit in this case, say. But at the same time, we have to make sure that that new decision is actually feasible, meaning it has to satisfy the original constraints of the problem. But that's actually easy to see in our tableau. We want to make a decision so that when we change the tableau, the numbers on the right are still positive numbers. If one of them is negative, that's telling us that that new decision that we've decided to make is not feasible because it's used more than the available resources available. So if any of these numbers turn into a negative as you're doing these problems, you know you made a mistake. So the pivot column choice is easy. You just pick look at the negative numbers in this last row, and you pick the leftmost one. And again, we're only considering columns underneath our variables in blue. So in this case, X, the X column is our pivot column. So we want to swap that out with one of these three variables on the left. So we need to pick which row is going to be our pivot row so that we can swap those variables and then manipulate the numbers in the matrix or the tableau to get a new tableau, which we can then determine if it's optimal or not. Choosing the pivot row is easy as well. All you're doing is you're taking the numbers in the right-hand side under the remaining resources, and you're dividing them by the corresponding number from the coefficient of, in this case, X, because that's our pivot column. So we're going to do 150 divided by 1, which is the 150 we see over here. We're going to do 200 divided by 3, which is the 66.67 over here. And we're going to do the 175 divided by 5, which is the 35 over here. And because 35 is the smallest, that's our pivot row. So what we're going to end up doing is swapping out X and S3 so that S3 becomes 0 in our new decision, and X will become non-zero. So what that means is our next decision will tell us to make a certain number of product X. But it'll tell us also that S3 is 0, which means making that decision leaves no remaining resources available for S3. Well, I'm sorry, that's not necessarily true, but it'll say in our decision that will be what our decision is. All right. Computing these ratios is just arithmetic, but you can do it in Excel pretty quickly. You go into this cell over here and just type equals. For example, let me just go ahead and do this. Type in equals, click on the number on the right, 150, and then divide by the number in the pivot column, 1, and hit enter, and it computes it for you. And then you can hover your cursor over the lower right-hand corner of that cell until it becomes a black cross, and then drag it down, and it'll compute the others for you. So that's how we decide on the pivot row and pivot column. In the next video, we'll actually perform the pivot to get the new tableau and the new, more optimal decision.